This is the lesson for Algebra 2-2. So what we're doing today is identifying the parts of a linear equation modeled in given situations. So we're looking at some word problems and graphing it from there. Remember that the independent variable is also called the input. The output is the dependent variable. Your rate of change, you're looking for keywords like per, each, every. All right, that's the m in your slope with y equals mx plus b. It's this letter that's in front of the x here. And then your y-intercept is the number that it starts at, or something that happens once. And that is the plus b in your equation. So taking a look at this word problem, it says at 36,000 feet, the crew above a 747 airplane begins making preparations to land. The plane descends at a rate of 1,500 feet per minute until it lands. Descends means that it goes down. Compare this problem situation to the problem stated in lesson 2.1. How are the situations the same? How are they different? Well, they're the same. They're the same because they have the same independent and dependent variables. All right. The independent is your time. All right. That's the time in minutes. And the dependent is your height of the plane. Now, the difference between the two is that in the previous section, the plane was ascending. It was going up. Now it's descending, so it's going down. So the rate of change is different. When it's positive, it's going to go up. When it's negative, it's going to go down. So let's take a look at what this would really look like. If we're filling out our table here, the independent quantity, remember quantity is always your time. So that's what we're looking at here. This is your time. How are we measuring the time? More specifically, we're measuring the time in minutes. When we take a look at the dependent quantity, we're measuring the height of the airplane. And how are we measuring that? We're measuring that in more specifically in feet. Remember that the quantity is more generic. The units are more specific. So we need to come up with a function. Notice that it says to use g of t, all right? So when we go to write this function to represent the problem, it said that the plane was starting off at 36,000 feet. So starting off at 36,000, and it was descending or going down 1,500 feet per minute. So 1,500, they want you to use t, all right? So we're gonna say 1,500 t. This would be the g of t, because that's what they wanted you to use. Make sure you always use the letters that they want you to use. If it has a t in the parentheses, you need a t in your expression or your equation, not an x. So it's starting off at 36,000. It's decreasing 1,500 feet per minute. So minus 1,500 times the number of minutes. So again, you could type this right into the calculator. Type it into your y equals, and then do second and table to show you the values to put into our table over here. Well, I'm just going to do that for you. 0 is really 36,000. And again, you could just take these. Remember, these are your x values. These are your y values. So you could type these in and sub them into the t for 1,500. This next one is 33,000. Then we have 30,000, 27,000. Now, in your table, you'd want to look at the y values to figure out your x values. So where is it at 18,000? Where is it at 6,000? Just scroll down in your table. So this would be 12 and 20. They want your expression down here. So we would have 36,000 minus 1,500t. Sometimes they have the expression here. Sometimes they put it right here. It varies based on the individual question. So again, you could just use the table. That's the easiest way to do this, or you could sub in the values individually. So be very careful. When it asks you to find the x values, if we were going to do it the subbing in way, this 18,000 and 6,000, you'd have to sub in here and set up like 18,000 equals 36,000 minus 1,500t. You'd have to do it like that. But if we were trying to find one of these, just gonna switch colors, like the 0, you would have to sub it into here in your equation. So just be very careful on where you're subbing it into. So now graphing it and answering some questions from it. All right, they want you to graph the function using the points from the table. So it said that 0 was 36,000, so I'm going to put a dot right there. We had 2 being 33,000, so 2 and 33,000. You just have to estimate a little bit. Then we have 4 and 30,000. Again, estimating a little bit. 6 and 27,000. Notice that's forming a straight line. 12 and 18,000. And then we have 20 and 6,000. So there's my graph. This would be a straight line. And it would go all the way down to the bottom until the plane lands. We would not put arrows on the ends of these. All right, we would not put arrows because you couldn't have negative feet. All right, a plane can't go underground, and you also can't have negative minutes going back this way. So we're not going to put arrows on the ends. So now they want you to solve the following by reading the graph. They don't want you to do an equation. They want you to read it from the graph. So the f of 8 is right here. So if I go up to my graph from 8, I'm at 24,000. So at 8 minutes, the plane is going to be at 24,000 feet. For my other one, they want 14,000. So 14,000 would be halfway between 16 and 12. If I go over and go straight down, I'm at approximately a little bit over 14. If I had to say from reading the graph, I'd say maybe 14.5 from the graph. And that, again, that is just an estimate. All right, that's just an estimate. If you wanted the exact number, you would have to set up an equation and say 14,000 equals, our equation was 36,000 minus 1,500 t. So if they wanted you to do it exactly, you'd have to sub it into here. All right, but they just want you to read it from the graph on this particular question. On the homework today, you're going to have a question that they're going to give you the equation. All right, that equation is already graphed here on the line. They want to know when f of x equals 720. So 720 would be right here, all right, because we're counting by 80s going up along the side. So go over from 720 until you hit your line, go straight down. So this point is at 12. Joe has $50 from his birthday. He also works a job where he earns $100 per week. The situation is modeled using the function giving M of W, money in terms of weeks, equals $100 per week plus his $50 that he started off with. Remember, input is the independent. That's always your time. More specifically, we're talking about weeks here as your time. Output, we're talking about money. Or if you wanted to say dollars, maybe. Your rate of change, that's how much it's changing per week, all right? That is the number that goes in front of your variable, so that is 100. The Y-intercept is where it starts off at. That's going to be, he's starting off at 50, because he had starting off with $50. Amber's fish tank has 150 gallons of water in it. She dumps it at a rate of 10 gallons per minute. The situation is modeled by G of M equals negative 10M plus 150. It's negative 10 because the gallons are coming out of it. So again, input is minutes, because that's what we're talking about here in this particular problem. Our output is the gallons of water. The rate of change is negative 10 because it's decreasing by 10 gallons per minute. And the Y-intercept is 150 because that's where it's starting off at. Again, your rate of change is always the number that's in front of the letter, and your Y-intercept is your plus or minus whatever. Sometimes they're going to have you find the intersection point algebraically. If they gave you f of x equals 3x plus 10, and f of x equals 16, what is this really asking you to do? It's really asking you, when are they equal to each other? So all that you would have to do is set them equal to each other and then solve. So minus 10 is just a two-step equation. 3x equals 6, divide by 3, x equals 2. So at x equals 2, that's when they are equal to each other. Again, we would do the same thing here. We have, these are two separate questions, by the way. We have m of t equals negative 20t plus 54, and m of t equals 14. Again, all that we would have to do is set these two things equal to each other and then solve. So we would do minus 54, minus 54. So negative 20t equals negative 40. Divide by negative 20, divide by negative 20, and you would get that they are equal to each other at t equals 2. Let's take a look at another word problem. Pot of water starts out at 35 degrees and increases 7 degrees every minute. When will the temperature be 100 degrees? So if it starts off at 35, increases 7 degrees every minute, so 7 times the number of minutes. When will it be exactly 100? You would set it equal to 100. And then we would solve that. Minus 35, minus 35. So 7m equals 65. Divide by 7, we would have approximately 9.28 minutes. That's approximately when it would be equal to each other. Go ahead and try this problem on your own. You can pause the video. Cookie Monster started off with 50 cookies. He ate 4 cookies per hour. The situation is modeled with the equation cookies in terms of hours equals negative 4h, because you're subtracting 4 cookies every hour, and you're starting off with your 50. So what is the rate of change? The rate of change is that negative 4, because you're eating 4 cookies per hour. The Y-intercept is your 50, because that's what he's starting off at. When will he have 10 cookies left? Now notice how it's written, C of H equals 10. We're going to take that and sub it in right there in the equation. So instead of C of H equals, we're going to have 10 equals negative 4H plus 50. So minus 50 minus 50, so negative 40 equals negative 4H. Divide by negative 4, divide by negative 4, and you get that H equals 10. So after 10 hours, he would have 10 cookies left.